Hi, this is Mike, WB4HUC, and in this video I'm going to just walk through the two little programs I wrote that I talked about in my previous video about the Auto ADIF, Automatic ADIF Logging feature that's recently been added to the Logic Logging software. So if you haven't watched that video, just don't go any further with this one. Go watch that one and give you some context for what we're talking about here. So with that, we'll just get started. So I wrote two little programs, and by little I mean this one is 128 lines long. This one is 136 lines long, so they're very short. And what they do is, as I discussed in the other video, is when records are added to the WSJT-X log file, these programs go grab that record, that most recent record that was added, and add fields to it that I want logic to see that are not already in the ADIF file. I've got some custom fields and some other things, as I discussed, that aren't in the record as it comes out of WSJT. So these two programs read the WSJT log file, grab the most recent record that was added to it, add the extra fields that I want to add, save it, and then Logic, as soon as I save the file, Logic uh, grabs that record, which now has the original WSJTX fields that program wrote, plus the fields that I've added to it that Logic wants to see. So this is the first of the two programs. And I'll talk a little bit about the programming language that I used because it isn't well known outside of a fairly small group of people. But it's called Rex. It was invented around 1979 by a fellow at IBM, and then it became the official scripting language for IBM's operating systems, VMCMS and MVS at the time, ZOS today. But MVS at the time, and it may have been added to DOS, the DOS operating system. I'm not sure. I never fooled around with DOS, but certainly for VMCMS and MVS. And it's a small language in that there's only like 35 keywords, but there are a lot of internal and external functions, and functions are just, if you don't know, think of them as tiny little programs you can call to do something. So if you want to count uh, all of the characters that are in a data string, you can do that with a function. If you want to convert a number from hexadecimal to decimal to octal to whatever, you can do that with a function. If you want to do things with the date and time, there are functions for date and time. If you want to, I'm trying to think, there's just all kinds of functions you can execute within the language. And then the language also talks to the operating system. So whatever that might be. Rex, as I said, started out at IBM, but since then there were versions for MS-DOS or probably any of the DOS operating systems that ran on IBM PCs. For Windows, which is what this is, it's a version of Rex that runs under Windows. For Linux, for Unix, for the Commodore Amiga, back when the Commodore Amiga was around, and even for Apple, I believe, although I don't remember if the Apple version was for the old Apple II or if it's for the Macintosh computers. And if you ever owned a Palm Pilot or one of the Palm OS PDAs, there was a version of Rex that ran on those things. So Rex can run just about anywhere, and it's very portable. The same program that runs under Windows can run under Linux with little or no changes depending. File I/O, reading and writing files is a little bit different on each operating system, I guess. So, um, or could be. So you might have to make some tweaks and adjustments to that part of the code depending on, if you move from one operating system to the other. But basically, it's a portable language. that'll run just about anywhere. I like it a lot. I've been programming in it since 1986, uh, and today it's my favorite language. So now that I got that out of the way, let's just look at this code. So anything starts with a slash asterisk and ends with an asterisk slash is a comment. And programmers know they should put lots of comments in their code. So when this program starts, first thing we do is we assign the actual file name to this variable log file. So we can use this thing 50 times in our program, and if its file name changes, we just change it in one place, and then it gets changed everywhere we use this name. And then here we're loading up some external function libraries to do some of those things that I talked about a minute ago. And then we come down here and we write out our little report heading, which is this stuff. And then I thought I closed it. And then we go down here and we get the last date and timestamp for the file. In other words, the last time it was updated, and we save that in these places. Then the next thing we do is we read all of the lines that are in the log file, because these are sequential files. You read them from top to bottom, and in order for us to get to the bottom, we have to read all the records, in the file, and then we're at the bottom of the file, so that when WSJT-X adds a new record and we go to read the record, we read the last one that was written, and we don't read it until it was added. So anyway, we just position ourselves to the bottom of the file. Then we have this little do forever loop, and that's literally what it means, is it'll go into this code and it'll just stay there and run for all time. The only way to stop the program is to come up here and just end the window, little DOS window here, and that'll stop the program. Won't hurt anything. It won't mess up the file. That's just in this particular program, that's how you end it. Not all programs are done that way, of course, but this one is. So we come down here and we get the date and time again, and then we compare that current date and time to the date and time that we got up here, and if it changed, we know a record was added. If it didn't change, a record wasn't added. So if a record was added, we'll fall through and we'll do this stuff. If a record was not added, we'll just go to the end and then start over and do this all over again. So let's say that the new date and time is different from the old date and time. Then we will reset the old date and time to the current date and time, so that the next time we come through, we can do this comparison again. Then we'll go read the log record. That's a little subroutine inside this program. So we're going to go here. We're going to read a record from the log file. And the WSJT log files look like this. So they are, I should have made this window a little bit wider. So one record goes from here to here, even though it covers 3 lines in the editor. These 3 lines all together make one physical record. So when we read this whole thing, except to be precise about it, we read this one since it's the end, most recent one added, but it's the same thing. You got 3 lines in the editor that make one physical record. So since we're reading in a big long string of data, we got to figure out the separate fields. So that's what this parse command does. He'll read in that whole long string and he'll break it up into its separate fields. Now, at this point, a separate field is going to be, so it's delineated by spaces. So the way that Rex knows that each of these fields is different is he looks for a space. And when he finds a space, he knows he's come to the next field. So a field then consists of the ADIF tag, the length, and then the data. And if you go down here, ADIF tag, the length, and the data. So that's a field at this point in the program, comprised of the tag plus the data. So we've broken these up into their separate pieces. Now this is just a little piece of code I wrote, and all it does is lines up the numbers in the call sign. So it looks kind of odd at first, but for me, I don't know, I just like seeing the numbers lined up, even though some of them are indented and some of them are not. I just did that because I like it that way. And then down here, we're gonna get just the data piece out of each field. So remember, we said a field was made up of the tag and the data. Well, that little section of code we're going into now will separate out this data part so that we know it's data. I just changed that field, so I best not save this file. So we're just going through each of these fields that we broke out of the big piece of data, and we're separating out the data part, and then we're going to add slashes in between the month, day, and year of the date. We're going to add colons between the hours, minutes, and seconds of the time, so that when he writes out the record, it looks like this. And then when we get down to the end, we do a return, which means we go back up here to where we came from, and then we continue on with this statement. Say is, if you've ever programmed in BASIC, it's like a print statement in BASIC. So that's when we write out these lines. And then we call this program. And this program is the one that is past one record, which is the record we read in, because this program doesn't read a file to get a record. The record is given to him through this field in memory. And then when that program is over, we come back, we hit this end, and then we go back and start another loop. But now we're going to call this program, which is here. And this parse statement simply brings the record into the program where he can see it. And again, it looks like this. So, so we're going to do the same kind of thing. We're going to initialize our variables. We're going to assign another file name, but this time it's the file name that this program is going to write. And so when this record is written out to the file, Logic will then pick up the most recent record added and bring it in and add it to his log. But by then it will have extra fields added to it. So the stuff that this program adds is not in the original log record. So that's the whole purpose of this, is to add those fields. So anyway, we come down here, we define some field names in here, assign some values to some field names, and then we do it again for some different kind of data. So basically what these things do is the program is going to look at the band field, and then he's going to come up here and know what frequency we want to use for that band. And I'll explain in a minute why we do that. And it's the same thing for the antenna. He's going to look at what band we're on, and then he's going to come up here and know which antenna we use to make that contact. And that's just pieces of information that this antenna field is a custom field I added to the logic log form. Frequency was always in the logic log form, but I'll tell you why we go to this trouble to do this. So we make these assignments, and then we come down. We do the same thing here we did in the other program. We take that long string of data and we break it down into the fields just like we did before. And then we need to know if we added a comment to the record or not, because what we do is, in this file, there's a comment field that I use to know which radio made the contact. Again, that's just another piece of information I track because I want to. So if I use the Omni 7, I put Omni in here. If I use the IC 7300, I put 7300 in here. In the comment in the WSJT-X program, when you get ready to log, there's a comment field, and that's where I put it so that it ends up here. So we figure that out. And then the way that WSJT-X specifies the frequency, see if we can find it. Here we go. So here's one, frequency. So it's 7074 plus the audio tone offset. So it's the VFO frequency plus the audio tone offset. Well, I don't know if I have that many digits in Logic to store a frequency. I don't think I do. I think it might go out to 3 digits. I don't really know. Maybe it would take the whole thing, but I don't really like that. So what we do here then is when we get to it, I'll show you what we do. Well, it's right here. So we're going to find the band in the band field, and then we're going to say if we're going to say that the frequency field is going to be equal to what's up in this table. So if we go back up to this frequency table, we see if the band was 40 meters, we're going to end up with a frequency of 7074. If it's 20 meters, we're going to end up as 14074, etc. So it's just a look up in a little table is all it is. And that's much faster than putting a bunch of if statements in here that say if band was 40, then frequency equals this. If band was 20, then frequency equals that. That's a lot of code to add. That if you added bands 60 meters, for instance, you'd have to add, more code, but 3 or 4 or 5 more lines of code. But if I ever added 60 meters to this now, I just have to stick it in the one line in this table, and he would just go look it up. And same thing for antenna. The antenna field is going to be the antenna name plus the band. So if it's 40 meters, it's my double bazooka. If it's 6 meters, it's my 5-element beam, etc. The reason I have a better antenna on 6 meters than I have on HF is I like 6 meters more than I like HF. So, we make these assignments to fill out the frequency and the antenna fields that we're going to add to our our ADIF record. And then we're going to come down here, and if the comment was Omni, we're going to set the rig to the Omni 7. If the comment said 7300, we're going to say 7300. And then here's some fields that we don't have to derive from anywhere. We're just going to hard code them. So we're setting QSL received and sent to blanks. We're setting the LOTW QSL received to requested. And then if I go and download my LOTW contacts, if I get one from a station where it's set to requested, it'll change it to an F for fulfilled. Then I set the operator and my grid square. So these are just hard-coded assignments. Then when we write the record, we actually write many records. So if you notice in each of these write statements, we write to the same log file, but we write different fields. And this puts each field on a separate line in the file. I do that because I think it looks better. It creates more records in the file than so the output file is going to have more records than the input file had. But it's easier to read. I like it that way. If you miss something, it's easy to find. If it's supposed to be on its own line, it's easier to find than it is if it's buried in all of this stuff. So we write out all these fields, and then we write our end of record tag, and then we write out a blank line, and then we'll close the output file. I put a 1-second delay in here. I can't remember why. I'm not going to worry about it. And then we close the file. And this is where the magic happens. So as soon as we close this file, the date and timestamp gets updated, And then Logic knows that there's a new record in that file, and he will automatically go get it, as we saw in the demonstration in the previous video. So that's it. And since this operates on only one record at a time, once we reach the end, we just quit. And then when we quit, we go back over here. We call after, and then we come back to here. Then we go back to the top of this loop, do it all over again. And so that's how we know a record's been added, by checking the date timestamps. I'm assuming that's how Logic knows, but he might do it a different way. And that's it. So we basically read a record, we parse it out to print a report, we call this program to take the single record and add the fields to it and write it out to the output file that this guy writes, which is the input file to Logic for the import. And the records that this guy writes look like this. So each field is on a different line, and things are much easier to see if there's an error or something's missing. And then we just keep writing to the file, and Logic only picks up the most recent one. So if there were records in the file when you start Logic, he may do the same thing I did to skip to the bottom. I don't know what he does, but however he does it, when he imports, he only reads the most recent record, updates his log database and the log form as I demonstrated in the previous video, and that's it. So there you go. Two small, short little programs, like we said, 128 lines long and 136 lines long, and they're pretty simple, yet they've performed a very useful function for me. So whatever language you use, you can do this in C language, you could probably do it in Python, you could do it in, I don't know, I suppose you could do it in Java if you're a Java programmer. You can do this in probably any language. I just picked Rex because that's my favorite, and I know it. And Rex is very simple, straightforward, as you can see. Not a lot to this program. Anyway, with that, I'll just say I hope you enjoyed the video, and thank you for watching.